Hello class, this is Miss Albritton of Albritton's Math Class, AMC. This video we're going to look at solving quadratic equations using a method called factoring. However, with this method we're going to look at when the a value is greater than 1. Now we've already done some solving using the factoring method when the a was equal to 1. So what do I mean by that? Let's take a look at the standard form of a quadratic equation. So here is standard form. We got ax squared plus bx plus c equals 0. Now, a is a coefficient that is in front of the x squared term, b is a coefficient for the x term, and c is a constant, which is a number without a variable. Notice it doesn't have an x with it at all. So here's an example. 2x squared plus 7x plus 6 equals 0. Now, let's identify the a, the b, and the c in this example. So the coefficient that's in front of the x squared term, the 2, that's your a value. And it is greater than 1 in this case. The b value is our 7, that's the coefficient in front of the x term. And the constant, which is the number without a variable, is 6 in this case. Now, we're going to actually use a method of factoring called the AC method. And this is what I'm saying. I am saying the AC method. Notice we got the variable a and c side by side. That means a times c. So that tells us we're going to multiply the a value times the c value. In this example, a is 2, c is 6. So we're going to multiply 2 times 6. Now, this is the first step. So first step for using this method, and remember we're looking at an example where the a is greater than 1. So first thing that we're going to do is going to rewrite the first term and the last term. So I'm going to just rewrite those. I'm going to bring down the 2x squared, and I'm going to bring down my plus 6 equals 0. So I didn't change anything. I didn't do any computation yet. I just rewrote those. Now this is where the calculation comes in. We're going to take the b value, the 7x, and we are going to break that apart using a times c. Instead of just using the constant like we had done before when we were doing just a equals 1, we're going to do the coefficient in front of the x squared term and the constant multiplied together. So 2 times 6 gives me 12. 12 is the number that we're going to list the factors of. Because if you recall, we listed factors of the original constant with the other method, and we broke it apart and we looked for a factor pair that combined to give us that middle term, that b value. So let's look at the factors of 12. They are 1 times 12, 2 times 6, 3 times 4. These are all the factors of 12. So all of these multiply up to 12, but which pair will combine or add to give us 7? That's what we're looking for. So I'm going to combine these. That gives me 13, so that won't work. 2 and 6 gives me 8. That doesn't work. And 3 and 4 gives me 7. This is the pair that we're going to use in order to help us solve this equation. This is what we're going to do. So we're going to take this 7x and we're going to split it into 3x and 4x. So all I've done is I've actually split up the 7x into 3x plus 4x. Now, next step, we're going to group the first 2 terms and the last 2 terms together. And by grouping, I'm just putting parentheses around them to show that those two go together. They're grouped together. All right? Next step. We're going to look at each of those groupings and see if we have a common factor that we can actually pull out of those groups. So let's take a look at the first group. I've got 2x squared plus 3x. And the only thing they have in common is an x. So I'm going to actually pull that out. I mean, literally pull it out. So I'm going to put the x out here. And then I'm going to look at each term separately and find out or ask myself what's still remaining. When I factor out an x, what's still there? In other words, what's the other factor? So when I pull an x out of 2x squared, I've got 2x left. And I can prove that because if I use the distributive property and I do x times 2x, I go back to 2x squared. Now I'm going to do the same to the other term, the 3x. So when I pull an x out of 3x, all I have is the 3 left. I can prove it. X times 3 is 3x. We're going to do the same to this grouping. So I'm going to take a look at 4x plus 6, and I'm going to ask myself, what do 4x and 6 have in common? The only thing they have in common is the 2. So I'm going to actually factor a 2 out of that grouping. And I literally mean I'm going to pull a 2 out to the front. Now, when I factor a 2 out of 4x, I have 2x left. How do I know? 2 times 2x is 4x. And when I factor a 2 out of 6, that's a 3. Because 2 times 3 is 6. And then they're all still set equal to 0 because that's the solving part. Now, I want you to notice something. Notice that this expression in the parentheses matches that one. They should match when you're using this method because they're going to make up one of the factors of this equation. What do I mean by that? Well, this is the point where we actually list our factors, which are going to be 2 expressions, it looks like. And let me tell you how the first factor looks. The first factor is made up of the outside terms, the terms that we pulled out of the parentheses. So we pulled out an x and a 2. So that plus 2. So the outside terms make up one of the expressions or one of the factors, and then the matching inside terms make up the other. So here's our factors of this quadratic equation. Sure, they're expressions, but that's okay. They're still factors. And factors just means if we multiply this times that, we get this expression right back. Just like over here with these factors of 12, if we multiply this times that, we got 12. 2 times 6, we got 12. Same here. These are just factors. Nothing that you haven't heard of before. But we're not done. All we've done is factored this equation. We still need to solve for the variable. We need to know what x is equal to. We have some unknowns here. So this is at the point where we separate these and we set each of those expressions equal to 0 and solve for x. So let's do that. So I'm going to put x plus 2 equals 0 and 2x plus 3 equals 0. And now let's solve for the variable. Now this is a one-step equation. One-step equations are pretty simple. We know that we need to get x by itself because to solve an equation, you want to isolate the variable. Well, the only thing that's over here with the x, and when I say over here, I mean on the left side of the equal sign, is a plus 2. What's the inverse of plus 2? Right, minus 2. So I'm going to minus 2 here. Now keep in mind when you're solving equations, whatever you do to one side of the equal sign, you have to go and do to the other side. So I'm going to do a minus 2 over here also. These cancel. X is left, so I've isolated x on one side of the equal sign, and then what's left over here, 0 minus 2 is minus 2, or negative 2, or subtract 2, whatever you want to call it. So this is the first value of x that we have. Let's do the same over here. Now this is not a one-step equation, it's a two-step equation. All that means is we've got to do 2 inverse operations to solve for x. Now you always want to start with a constant, which is a number without a variable first. Since this is 2x plus 3, the inverse of plus 3 is minus 3. Whatever I do to one side, I have to do to the other. Now these are going to cancel out to 0. What's left on the left-hand side is 2x. So I bring that straight down, I bring my equal sign down, and I calculate 0 minus 3, which is minus 3. Or you can call it negative 3 or subtract 3. They're all the same. Now notice, I still don't have the x isolated because there's a 2 in front of it. A coefficient. This expression reads 2 times x equals negative 3. Well, what's the inverse of times x? Yes, divide x. So I'm going to divide by 2 because this is the number I want to get rid of. I want x to be the only thing over there. Now, whatever I do to one side, do it to the other side. So I divided 2 over here, I divided over here. But what happens here is it cancels out. Because 2 divided by 2, anything divided by itself is 1. And 1x is just x. So I bring down my x, isolate it just like over here, equals, and the only thing I can do with this is just bring it down to. That is a valid answer. That is a solution. So the solution for this quadratic equation is x equals negative 2 and negative 3 halves. Or negative 3 over 2. So there is the solution for this quadratic equation. All right, so that's the AC method, and I'll see you on the next video.